Okay, so in this video on standard normal distribution, we are going to have a look at Z values involving sandwich inequalities. So you can see the steps here: draw a sketch, split it into its parts, solve separately, and answer. Parts 2 and 3 will depend on how the question is asked. If we're dealing with, what type of inequality, or if it's a plus or minus. Okay, we'll start off with part 1. So we're asked for the probability that 1 is less than Z less than 2. So the parts I've written up in blue, assuming Z is normally distributed with a mean of 0 and standard deviation of 1. You'll see that written at the top of the questions. That's how we know we're allowed to use this process. Okay, so a quick sketch. So we have our mean here in the middle, and they're looking for the probability that Z sits between 1 and 2. So there's all my area in between. So if I look at that, I know I can't figure out the area to the right of 1, but I can figure out the area to the left of 1 and the area to the left of 2, subtract them from each other, and I'll be left over with this balance. So that helps me set up my inequality here. So I'm going to figure out the probability that Z is less than 2 and subtract the probability that Z is less than 1. So what that looks like in terms of our curve. So it'll be, there's 2, there's 1. This first time I'm going to figure out all of this area. Second time I'll figure out this area, and then when I subtract them, I'll be left with the area that sits between 1 and 2. So what we were asked for originally in the question. So this sketch kind of helps us signpost what it is that we need to do. So first step, probability that Z is less than 2. Enter log tables. Pretty straightforward. 1 here, so there's 2.00. So that's 0.9772. The probability that Z is less than 1. And 0.8413. And now we'll subtract 0.9772 minus 0.8413 into our calculators. And we get 0.1359 or 13.59%. Okay, that's part 1 answered. Part 2 now. We're asked for the probability minus 1.4 less than or equal to Z less than or equal to minus 1.146. Okay, we'll draw a quick sketch again. So we have, let's say that's minus 1.4, and then here 146. Okay, so we're being asked for the area in between here. Now, in terms of these inequalities here being less than or equal to, when we're dealing with Z values, the inequality is less than or equal to, and then greater than or equal to. We treat them the same for the log tables. So for this, I'll be looking for the probability that Z is greater than or equal to minus 1.4 if it was a single inequality, or the other one would be Z is less than or equal to minus 1.146. Okay, so back to the question. So if we see here, Again, we can figure out the area here to the left of minus 1.146, but we cannot figure out the area to the right of minus 1.14. So we'll split it up into its shapes. So I do know I can figure out minus 1.146, this area here. And then if I subtract the area to the left here of minus 1.4, then that will leave me with what we're looking for in the question, the area in between the two values. So minus 1.146 and minus 1.4. Okay, so that helps me rewrite my inequality. So it'll be the probability that Z is less than or equal to minus 1.146 minus the probability that Z is less than or equal to 1.4, minus 1.4. Okay, now we see that both of these are negative signs, so we need to deal with that itself. So we have the probability that Z is less than or equal to minus 1.146. Change the sign forces us to change the inequality. Greater than or equal to 1.146, which we know we can't figure out, so it's 1 minus the probability that Z is less than or equal to 1.146. Okay, and then the second one, we have the probability that Z, give some space, the probability that Z is less than or equal to minus 1.4. Now, let me see. Oh yeah, we're okay there. So it'll be the probability, I change my sign. Z is greater than or equal to 1.4. So it's 1 minus the probability that Z is less than or equal to 1.4. Okay, so for this one here, we go to our log tables as normal, 1.146. So we have 1.1. And then if we look here though, we run into a bit of an error. So we have 1.146. We have 1.14 and 1.15, but 1.146 sits somewhere in between. So what we're going to do is we'll look at both values here. And we'll divide by 2 to get the value that sits halfway between. So it's a bit of an approximation, but it's the best workaround to it. So we get 0.8729. And our other value then is 0.8749. We're going to divide that by 2 into our calculators. So we have 0.8729 plus 0.8749 divided by 2 will give back 0.8739 into our calculators. 1 minus that gives me 0.1261. And our second one here a little bit more straightforward, so we're looking for 1.4. Back to our log tables. We have 1.40, 0.9192. So 1 minus 0.9192 will give me 0.80, 0.0808. Okay, so again, back up to our inequality at the top. It's the probability that Z is less than or equal to minus 1.146, which we have figured out to equal 0.1261. And we're going to subtract our second one, which is 0.0808. into our calculator 0.1261 0.0453 or 4.53%. Okay, that's part 2 answered. A little bit more awkward than part 1, but once you sketch it out and remember the 4 rules from the previous video, it's an okay question to answer. So part 3 then asked about the probability that Z is less than, greater than minus 1.2 and less than 1.75. So we have minus 1.2. It's less than 1.75. Okay, so as always, we're going to draw a quick sketch, figure out what we're being asked to find. So we have here minus 1.2, up here then 1.75, and they want the area in between. That's fine, so we know we can figure out the area to the left of 1.75. We can't figure out the area to the right of minus 1.2. So what's going to happen then is we'll figure out the area to the left of 1.75. So that'll give us everything there to the left, and we can subtract then the area to the left of minus 1.2. So what we have here, and that will give us the balance then, which is what they've asked for. Okay, that'll help us set up our inequality now. So what we need to do is the probability that Z is less than 1.75 minus the probability that Z is less than minus 1.2. Okay, so the first one, probability that Z is less than 1.75, pretty straightforward. We just go to our log tables. We're looking for 1.75. And that gives us 0.9599. And then we have the probability that Z is less than minus 1.2. We have a minus sign. We need to change that. So it's the probability. If we change the sign, we change the inequality. Z is greater than 1.2, which using our cases we can't do. So Z is less than 1.2. Probability that should be 1 minus to our log tables. We're looking for the probability of 1.2. There's 1.2 and 0, so we get 0.8849. Into our calculators, 1 minus 0.8849 will give me 0.1151. Okay, so then we get 0.9599 minus 0.1151 into our calculators. 0.8448 or 84.48%. Okay, so there's 3 examples on sandwich inequalities for Z values under standard normal distribution.